We now discuss the solution of a problem from the section differential equations. The given question is based on the solution of the given initial value problem. This question has appeared in the joint entrance examination main held on 26th June 2022 in the second shift. The given question is if y is equal to y of x is the solution of the differential equation x dy by dx plus 2y is equal to x e power x with the given condition y at 1 is equal to 0, then the local maximum value of the function z of x is equal to x square into y of x minus e power x, where x belongs to the set of real numbers, is, we are given four options. Option A 1 minus e, option B 0, option C 1 by 2, option D 4 by e minus e. Now we are given a differential equation x dy by dx plus 2y is equal to x e power x with a given condition y at 1 is equal to 0, and take this differential equation, get its solution, call it as y is equal to y of x. Then construct z of x, a new function that is equal to x square into y of x. This y of x is a solution of this differential equation minus e power x, where x belongs to R, and to find the local maximum value of this function z of x. That is our given question. We now discuss the solution of the problem in detail. We have this differential equation with an initial condition, that is the value of y when x is equal to 1 is 0. A differential equation equipped with an initial condition is called an initial value problem. And now our first step is to find the solution of the general solution of this given differential equation, then find the solution of this initial value problem. Now take that differential equation, divide throughout by x, then it takes the form dy by dx plus 2 by x into y is equal to e power x. It is of the form dy by dx plus p of x into y is equal to q of x. What is it? It is a first order linear differential equation in y. And to solve such a differential equation, we first find its integrating factor. The integrating factor is given by e power integral p of x dx. Then we obtain the general solution as y into integrating factor is equal to integral q of x, that is the right hand side function, multiplied by the integrating factor, integrated with respect to x, plus c, where c is the constant of integration to be determined. Now in our case, dy by dx plus p of x into y, so p of x is 2 by x is equal to q of x is e power x. Agreed. So we first find its integrating factor. Integrating factor is equal to e power integral p of x dx is equal to e power integral p of x is 2 by x dx. That is integral of 2 by x is 2 times ln x, right? E power 2 times ln x, and that is e power ln x whole square, that's equal to x square. So thus we have obtained its integrating factor, that is x square. Agreed. The GS is given by y into the integrating factor, that is x square, is equal to q of integral of q of x, that is the right hand side. The right hand side is e power x into its integrating factor x square dx plus c. So we obtain y into x square is equal to integral q of x e power x into integrating factor x square dx plus c. So that means yx square is equal to, if you integrate this e power x into x squared with respect to x, then you will get x square minus 2x plus 2 into e power x. That is the integral of this one plus c. So how do we integrate this one? We integrate this one by the repeated application of the integration by parts. That we will show you in this snippet. Integral x square e power x dx. Now to integrate this one, we suppose the first function is x square, the second function is e power x. So apply the integration by parts. So the first function x square into integral of the second, integral of e power x with respect to x, minus integral of the derivative of the first, that is the derivative of x square is 2x, into integral of the second, integral of e power x dx with respect to x. Now the integral of e power x is e power x only. Here also it is e power x, that is equal to x square into e power x minus 2 into integral of x e power x dx. Again we apply the integration by parts for this one, So take x as the first function, e power x as the second function. So that's equal to x square e power x minus 2 times in brackets first function x into integral of the second e power x dx minus integral of the derivative of the first is 1 into integral of e power x is e power x. So the total is integral of e power x dx. Agreed. And that will be x square e power x minus 2 into x into this one is e power x minus into minus plus 2 into e power x. E power x is common, so x square minus 2x plus 2 into e power x, that is the integral of x square e power x with respect to x. That is what we have written here. Agreed. What is this? This is the general solution. It is a solution involving an arbitrary constant, and hence it is called a general solution. So y of x, because y is a function of x, y of x into x square is equal to x square minus 2x plus 2 whole into e power x plus c. Agreed. That is the general solution of the given differential equation. So we take the initial condition and evaluate c in the next slide. The GS we have, and we have the initial condition. So given y at x is equal to 1 is 0. That means the value of y is 0 when x is equal to 1. Therefore, put y is equal to 0 and x is equal to 1 in the above general solution we obtain. So the y is 0. So 0 into anything is 0 is equal to x is 1. 1 square is 1 minus 2 plus 2. So 2 plus 2, 2 plus 2 minus 2 cancels, and e power 1 is e plus c. So you are left with e plus c is equal to 0. Therefore, c is equal to minus e. So thus the arbitrary constant is obtained. And now we obtain a particular solution. A particular solution is a solution obtained from the general solution for a particular value of the arbitrary constant c. So the particular solution is y of x into x square is equal to x square minus 2x plus 2 into e power x plus c is minus c. Agreed. Now this is normally the question what is asked several times in our examinations, but this time a new function is defined through y of x and asked to find the maximum value of that new function. So that means this differential equation, the solution of the initial value problem is now clubbed with the maxima minima of a function defined through the particular solution. So it's a question of hybrid in nature. Agreed. Now given z of x is equal to x square into y of x. Y of x is this particular solution minus e power x. So write down So x square y, we know x square y value directly, x square y value, that is x square minus 2x plus 2 into e power x minus e power x. Agreed. So that's your zx. So this we simplify still further. So this is minus e power x clubbed here, then you will get x square minus 2x plus 1 e power x minus e, and this is we find x minus 1 whole square. So that is equal to x minus 1 whole square into e power x minus e, that is zx. So therefore zx is this one. Required to find the maximum value of zx is equal to x minus 1 whole square into e power x minus e, and we find the maximum value of zx in the next slide. So we have zx is x minus 1 whole square into e power x minus e. To find the maximum value, that means to discuss about the maxima, to discuss about the extrema, that is the maximum and minimum, we first want the stationary points or critical points of zx. So they are obtained by taking the first derivative of zx. So z prime x is equal to x minus 1 whole square, first function, into derivative of e power x plus the derivative of x minus 1 whole square is 2 into x minus 1 into the second function e power x, and the derivative of e, that is a constant, is 0. So let us simplify this one. So x minus 1 is taken common. So you will get x minus 1 plus 2 e power x. So this is x minus 1 into x plus 1 into e power x. That means z prime x is x square minus 1 whole into e power x. Anyway, to obtain stationary points, we equate z prime x is equal to 0. We get x is equal to minus 1 and x is equal to plus 1 are the stationary points. And when you equate, e power x will never be 0. Therefore, these are the two factors which will give rise to the roots, and they are the stationary points. Agreed. Now we go for to talk about the maximum value of maximum, whether z of x attains maximum or not. To talk about that one, we take its second derivative. That means we are going to apply the second derivative test. So z prime x we know, differentiate again, you will get z double prime x, the second derivative is equal to, and z prime x is x square minus 1 into e power x, and 1, so the first function x square minus 1 into the derivative of second e power x plus the derivative of the first, that is derivative of x square minus 1 is 2x into the second e power x. Agreed. And in this we put x is equal to minus 1. So z double prime at minus 1 is equal to, with this minus 1 this becomes 0, and this will give you minus 2 into e power minus 1, that is negative, minus 2 e power minus 1, that is negative. Therefore z of x by the second derivative test, the z of x is equal to x minus 1 whole square into e power x minus e attains maximum at x is equal to minus 1, and the maximum value is given by z of minus 1. So substitute in z of x, go into this one, and x is equal to minus 1 you substitute, that will be equal to minus 1 whole square into e power x is minus 1 minus e. Minus 1 is minus 2 whole square is 4. E power minus 1 is 1 by e, therefore it is 4 by e minus e. That is the maximum value of z of x. So that's what is required. Let's look at our options. Our answer, the maximum value of z of x is 4 by e minus e, appears against option D. Therefore, the answer to this question is option D. That is the detailed discussion of the solution of the problem from the differential equations, and the solution of an initial value problem clubbed with the concepts of maxima minima is the given question. That is, it is a hybrid question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.